Hi, I'm Eric Kurman. I'm an engineering manager at Deposition Sciences in Santa Rosa, California. And I'm going to talk about a few things that occur in an article that we wrote for this show. The first one is coatings that are done on polymer substrates. That's really challenging. The main challenge having to do with polymer substrates is the mechanical properties of the polymer compared with what most people put coatings on, which is glass. So polymers are challenging because they have a higher thermal coefficient of expansion. Coating processes load the substrate with a little bit of heat, and they also have very different fracture properties than glass does. So glass has a high degree of compatibility with the coatings because it's metal oxides, just like the coatings are, and polymers are a little bit different. So that's an area where we're developing, and we're evolving our processes to take into account the specific challenges that are involved with polymers. The second one has to do with the replacement of the progressive replacement of incandescent lighting with LEDs. DSI has a very large interest in lighting because of our history, which we've been involved in lighting for a long time, and we're involved in improving the efficiency of incandescent lighting, and we're also getting more involved with LED. So LEDs present a challenge because they have a less of a broadband output than you would see with an incandescent light source. So the coatings have to be designed so that they will have the ability to color correct compared to what you would see with an incandescent. A lot of the interesting applications for LED are in things like airfield lighting, where reliability is a very high requirement. The third thing that we want to talk about is our patterned multispectral coatings. We have a couple of samples here. This is something that you're seeing people do more and more and more. DSI has been doing it for a long time. There's more competition, which is usually a good thing. And we have the ability to put pattern coatings on everything from very small substrates up to 150 millimeter size wafers. The last application area is broadband anti-reflection coatings on synthetic sapphire. The main interest in this that we have seen is to support UAVs, unmanned aerial vehicles, and these have to have a sensor suite in them that spans everything from the ultraviolet out to the near IR or even the mid-wave IR. Synthetic sapphire is becoming more and more available, progressively less expensive, and we see that as an area that's going to get used more and more in the future. And so we've developed some broadband ARs that will provide reasonable performance over that wide spectral region at some sacrifice in overall reflectance.